Okay, thank you. So I'm going to give a brief overview concerning our participation as a Moroccan to the Atlas experiment. So I will start giving some important dates concerning our participation, which started since early 1990, as our first contribution was in the contribution to the RDs of projects. I mean, we're setting up and running an irradiation, a neutron irradiation station for SARA facilities in Grenoble. And I will talk in one of my next slide in this, what is its aim and goals. And then after an enormous voted by our colleague in the Atlas, we become officially participated to this in 1996. And just 1 year after that, there is a creation of the Moroccan Moroccan cluster on high energy physics, which in the beginning was formed only by 2 universities, Casablanca and Rabat. And after that, there was other 3 universities. And also there is one center in Rabat, the Knesset. And we hope to have next year or another university, which is the Agadir University. And I will see that from this part, since this early 19th to 97, there are many exchanges, programs, actions between Morocco and other laboratories, either in France or in Sweden. And there is also a signature in 2004, a signature of the International Research Group between Morocco, France, and also Sweden. And here comes the idea to a construction of one of the parts of the, and the Atlas and the CERN, of course. This comes the idea of the reconstruction of one part of the detector. And also earlier 2008, there is another exchange, which is the International Associate Laboratory. And in 2010, there is exchanges action between Rabat and the IFIC groups in Valencia, and it is extended after 2 years, and it's composed now and introduced in the Valencia University. And in 2014, the area will be extended, and it will include other Maghreban countries. It will include Algeria and also Tunisia. So, as already mentioned in Sir John's presentation, the Atlas is in the LHC, collider, which is a high energy proton accelerator, which came on in September 2008. And there are, as shown by here is the ring of the LHC, and 2 beams of protons are going to be accelerated, and we will achieve approximately the speed of the light at nominal luminosity. And this beam of protons are going to enter in collision in 4 main parts in this ring, where 4 detectors are installed positioned in order to study the results from this collision of protons. And Atlas at IP1 is where our team or Morocco country is contributed, which I will give here in this slide, where the Atlas collaboration is, I can say it's the enormous collaboration in the world with more than 3,000 scientists. It includes actually about 1,000 students, and Morocco is the first African and Arab that becomes officially a member since 1996, as I already said. And here is a picture that shows the Atlas detector, which is a like onion detector, and use different technology which are complementary. And in the next slide, I will see, of course, here our contribution. I can divide it in 3. It's involved in several fields. The first part is an experimental part, from the construction of one part of the detector to the test beam analysis, And also we worked hardly in the calibration and also the alignment of the detectors. And the other part is in physics, and we study, as already mentioned by Sir John, in the physics in standard models, and also we are looking for signature and beyond the standard models by using also the real data. And also we are, as already mentioned yesterday's presentation, we are already also include the grid computing. And I can divide this in, we can divide it, our participation in 4 important phases. The first phase is during the constructions. I can see the constructions phase and also the test beam. And also in the commissioning phase, once all the subdetectors are already installed in the pit, so we have to see and to look for how is the electronics and the performance of detector. And the first signal is through to the cosmic rays, especially the muons. And after that, we go to the operating phase, which started since 2009, and we have also some in the future that we are going to included in working in the upgrade phases, and especially in the inner detectors. And we already start looking at this part. And so here I'm going to back to the first, and the first part is the experimental. And I see that since the beginning on the 90s, we started to the RD3 of the CERN project, and we set up and running one of these neutron irradiation station at SARA facilities in Grenoble. And the main idea here is to test, of course, the electronic and looking for the best electronics that will give us the best performance of our detector. So that allow us to choose the material selection for the LAR, for example, and also to reduce the attenuation of the signal, of our signal. And after that, of course, we went to another series after, of course, the SARA was closure. And here, as I see, always in the reconstruction part, both Morocco, France, and Sweden took responsibility of the reconstruction of one part of the detector, which is the presampler. We did actually here in Morocco mechanical and electrical parts by constructing over than 50,000 anodes of presampler, and we, of course, we did all their studies, and then these are sent to Grenoble to form what calls the modules, and then sent and form what calls the sector. And we can see here one wheel of the presampler after it's finishing. Okay, now I'm going to move to the other, the first part, which is concerning the test beam analysis, which can be divided into parts. The first part is from 98 to 2004. Our main participation is mainly concerning the energy resolution and also the study of the performance of the detector. And after that, of course, there is another one, which is the combined test beam after 2004, in which all shift detectors integrated, and we are using the correct, and which is run together with the correct data acquisition electronics, which is approximately is used up to today. For this, there are more 10 Moroccan physicists that went to CERN for this purpose, and then the working was mainly on the study of the detector performance, such as efficiency, resolution, and also looking for the noise of the our electronic, and also in the combined performance, such as material effects, particle identification, and so on. And also the most important part is also to validate the modelization of the Monte Carlo, and also to look for in the computing parts, and to have a common to participate, to have a common Atlas software. And also in December 2005, there was a combined test beam seminar that was held here in Morocco. So now, after all subdetectors are already in place, so before that, after they are included in the pit, there was a cold test, and Morocco strongly participated, and looking for the noise measurements, and also looking for the stability of the electronics through a part of time, several weeks, and we can see here in this plot. And also participation to the, as I will see in the next slide, the commissioning weeks, and also preparation to the, after their installation from 2006 to 2008. And here, since we participated on the pre-sampler construction, I can see that looking for the signal, the muon signal is the first exams to test our electronics, and we actually developed new tools and codes which are in the Atlas, software, and we are looking where we look for the signal of the signal of muons in this part, which is in this region of the pre-sampler. But here we can see, after we compare it with other parts of the detector, we can see that there is something which is missing, which is related to the calibration of this of the pre-sampler. That pushes us, of course, to go through this calibration, and we also not only to look for the calibration of this part, but also for the whole of the LAR detectors. And in this part also we look at all the parts, and we developed the new tools, since the idea was to automatize all these parts from data taken at the Atlas control room to the whole of the analysis. And also we participated to many other parts, which I'm not going to. And also we study, of course, the tracking system alignments in 2010. Here I'm going to now to move to the physics part. We, since the beginning, we start studying the Atlas physical potential, and also preparation for methods, in data analysis in different subjects and interesting subjects at LHC, from the standard models to beyond. And we can see here a lot of, lots of subjects, from the physics of Higgs physics to the B quark and T quark production, and also looking for the matter and antimatter through the CP violation in the B system, and also participation to the drafting of the technical design report in beginning of 2000. I'm moving now to since the Atlas, the LHC startup, we are looking for the analysis, the physics analysis. Our groups focused on many different aspects and subjects, which are so important, such as B physics. We are looking in this B physics also in one of the important things is to look at the B baryons measurements, such as its polarization and also its helicity, which is very important for many theory. Also the top quarks for many and numerous motivation. And in addition, we look also not only in the physics, but also in technical studies, such as measurements of the luminosity, and also looking for the beam spot, and also for the primary and secondary vertexing, and the alignment of the near detector, also the calibration of the triggers, which is so important, as we say in this event shown by John. So these two events are triggered, and this trigger have to be well calibrated. Now, what is the status and what are the progress? Since we participated on this collaboration, there are around 12 theses actually which are in preparation. 5 are planned to be defended by the end of this year, and also there are many analyses going on various subjects. And here I just pick up the last ILCP general meeting that was held last week, and where we can see that there is really a very diversity and advanced search subjects for this purpose. And I will thanks deeply Mr. Johan Kolo for maintaining this meeting so active. And so now, since this morning, we see what is the impact of our participation in this collaboration, especially for the youngest scientists. So up to now, we have about 15 theses which have been defended in the Atlas, and more than 100 internal publications. And we have actually about 15 PhD students which are working in both Atlas ELC, and also we get some expertise, and we move to looking also for the medical physics, for example. And since 2010, there is also one fellowship that have been set up by the Academy of Hassan and also the CERN. And of course, I will see here that the Sharing Knowledge Foundation played a leading role to maintain this to be from a dream to a reality. And also, we talk this morning from the diaspora coming from the country, from our Moroccan. There are several diaspora in different countries such as USA, France, and Europe, and United States as well. And this year there are 2 Atlas members that are integrated in the Moroccan university, and we also get expertise from this community, and we participated on international communities such as the Global Young Academy. And now here I just show here some pictures showing the signature between Morocco, between the Academy Hassan II and also the CERN. And we can see here diversity of people from the ELC area, and also from the Sharing Knowledge and the Carnot Foundation. Here we move now to the next and the last part, which is the grid computing. So the grid computing is an essential part, tools that is essential to me to do a physics analysis. There are a donation of 161 servers by the CERN to our university that are working in the collaboration, and also the Synergy. And the servers, as said by the CERN Director General, the server should allow Moroccan scientists who are mainly collaborating with the Atlas experiments to analyze LHC data at their home institute. Okay, now here is just a scheme concerning this grid computing. So at the Synergy, it will be a tier 2, and then the other universities are going to be like a tier 3 in order to analyze the LHC data in their home institute. And here just show some pictures, because several training have already been done since the server are installed and configured. And as mentioned yesterday, only the part of the server that goes to the Synergy, it increases up more than 400% the quota. And also there are the training of other new grid users. Here I'm going to move to one important things is, we know that Atlas this year is going to hold the Atlas Week overview in Morocco, and the websites and all registration are going to be start next week. So now I'm moving to a conclusion and the perspective. So from all what we see in our participation to this collaboration, from the RD to the detector exploitation, we established experimental expertise in the LHC accelerator in several fields, as already either in high standard electronics to physics analysis techniques to theory and energy physics, of high energy physics. Also developed of simulation techniques that have environmental and industrial impact, and we move it, as I said, actually to the physical medicine. Also, there are the training of young scientists in experimental and theory particle, and also data analysis. These, of course, give several scientists a benefit from participation to from collaboration in the international level, and also at numerous integration at numerous community, and also participation at other international projects in high energy physics, such as the SLHC, upgraded for 2020, and also from the International Linear Collider and the CALIS collaboration. Our other experiments at the national level, such as the Neutrino Observatory project in CESA. And thank you for your attention.